All right, in this video, we're going to be looking at how to solve a system of linear inequalities. Okay, the previous video, we learned how to solve a system of linear equations. Now, what's the difference? The difference is this symbol. The symbol that we use for inequalities, either the less than symbol, the greater than symbol, the less than or equal to, the greater than or equal to, those are all inequalities. Now, the difference between an inequality and an equal sign. An equal sign is telling us that something is equal to that exact value, where an inequality is saying that it's a whole bunch of points, either less than, more than, less than or equal to, or more than a value. So when we go to graph these, we're going to start by treating them just like linear equations, but we're going to choose whether or not we're supposed to use a dotted line or a solid line. So let's first start by just getting to where is this first line going to be. So just like we learned about in the previous video, we're going to start by finding the x and y intercepts. So to find the x-intercept, we ignore the y. So this has an x-intercept of 2. And to find the y-intercept, we ignore the x. So it has a y-intercept, that's also 2. We have an x-intercept of 2, a y-intercept of 2. Now stop. Don't draw a line yet. Because remember, what a line represents is a whole bunch of points that make up that line, an infinite amount of points that make up that line. So we need to figure out are the points on the line included? So we call this a boundary. So are the points in that boundary, are they included or not included? So here's how you can tell. We use a dotted line if we're working with less than or greater than. We use a solid line if it's less than or equal to those values, or greater than or equal to those values. So the indicator, the main thing to look for is the line underneath the inequality. If there's a line underneath the inequality, we use a solid line. So I'm just going to put a note to myself here, sometimes that's helpful as you're learning these, that for this first example, this first inequality, we're going to connect these with the dashed line, because our brain is going to want to connect these with the solid line. So sometimes just reminding ourselves that, in this case it's supposed to be dashed, is sometimes helpful. Now, the next thing we're going to do is we're going to graph the next inequality again by using our x and y intercepts. Oops, I'm going to have to do green. There we go. So if we were to cover up the y value, we would get the x-intercept is 6 for this one. And if I covered up the x value, I'd have negative 3y. So let's just do that for this one. It's a little bit more to see. So we can see now that we'd have negative 3y and 6. So to get the y by itself, I would divide both sides by negative 3. So I would get a negative 2 would be my y-intercept. Okay, so let's go to graph this one. Well, actually, before we graph this one, let's look to see what kind of line it is. So it's a solid line because it's less than or equal to. So when I go to connect these, I'm going to connect them with a solid line. So start with an x-intercept of 6 and a y-intercept of negative 2. All right, now this is we're not looking for the intersection here. We're looking to see what region these two graphs share. So now if you notice, there is a total of, different color here, there's a total of 1, 2, 3, 4 regions that are created with these two intersections. Okay, and I've talked about the quadrants. Okay, so if we could ignore everything except for this red line and the green line, we would have these 4 sections. In one of these 4 sections is where we would find all of our solutions. Why? Well, let's look. Well, first off, let's talk about testing points. So what I'm going to do is I'm going to test a point that's not on any of these 2 lines. And a really easy point to use would be the point 0, 0. So I'm going to use 0, 0 because that's not on the red line, it's not on the green line. So you want to pick any point we want, we can pick any point, as long as it's not on either of the 2 lines. And I'm going to use that point to test to see if we get a true statement or a false statement. What does that mean? So if I test that in the first equation, I would get, if I put 0 in here for x and 0 in for y, I get 0 plus 0, and I get the statement 0 is less than 2. So is that true or is that false? Well, 0 is less than 2. That is a true statement. So that means the area of the, so we're working with the red line right now. That's why it's helpful to have the colors here. So the area below that red line we would include, or we would shade. But we're going to shade it really lightly. Okay, now let's do the green line. So the green line, I'm going to use the same testing point. I'm going to put 0 in here for x and 0 in here for y. And when I do that, negative 3 times 0 is 0. So the left side is 0. That's why I like using 0 when we can. So I get the statement 0 is less than or equal to 6. That is also true. So for the area, I'll use a different color this time. There we go. So here's where 0, 0 is. 0, 0 is above the green line. So I'm going to shade above the green line. Now notice in that second region, that region there is where the solutions are the same. The shaded region is shared. So I'm going to shade that region. So with pen or pencil, you would just shade this region really dark, and that would be our solution set. So anything in that region would work in both inequalities. So if you picked any point in there, so I'm just going to erase this black section there for a second. And let's say if I pick a point like, let's pick this one, negative 4, positive 1. If you put negative 4, positive 1 into both of these inequalities, it should make a true statement. Negative 4 plus 1 would be negative 3. Negative 3 is smaller than 2. That is true. If I put negative 4 in here for x and 1 in there for y, well, negative 3 times 1 is negative 3. Negative 4 minus 3 is negative 7. Negative 7 is less than or equal to 6. So both of those are true statements. So I'm not going to do that for every problem, but I'm just showing you that any point in that region that we shaded in here real dark would be a point that would work in both inequalities. Now it says your turn, but I think we need a little bit more practice here. So let's look at this next one together. So this next one, again, we're going to start the same way we have been. I'm going to start with this one. I'll do this in purple. We're going to start by finding the x and y intercepts. Now I'm not going to write out x and y intercept every time. So to find the x-intercept, we ignore the y. So the x-intercept would be 1, because 3 divided by 3 would be 1. So again, make sure that you get the x by itself if you need to. And for this one, I'm going to ignore the x. So the y-intercept would be 3. And then we look to see, would we connect these with a solid or dashed line? The fact that it's greater than or equal to, we would connect these with a solid line. Now in the previous example, I used 0, 0 as my testing point, and I waited it to do it after I graphed the two lines. It doesn't matter if you wait to the end or if you even want to do it now. Some students find it easier to do right after we have the first point graphed. So that's what I'm going to do in this one. So I'm going to test, for this one, I'm going to test the point 0, 0 because it's not on the line. And I'm going to see if that makes a true statement. I put 0 in here for x, 0 in here for y. Well, 3 times 0 is 0, and plus 0 would also be 0. So I get the statement 0 is greater than or equal to 3. That is false. 0 is not bigger than 3. So I would not shade that side of the line that includes 0, 0, because 0, 0 is on one side of the line, and that point is not included. It does not make a true statement. So our solution set would be on the other side of that line. All right. So let's do this other one. I'm going to do the other one. I'll do it in red. I don't know why this is happening. There we go. Okay. So if I graph this one in red, again, we're going to find the x-intercept first, cover up the y. The x-intercept is negative 4. All right. Now let's find our y-intercept. Our y-intercept, we would have negative 4 divided by 2. Negative 4 divided by 2 would be negative 2. Now this one, there's no line underneath the inequality, so we're going to connect these with a dashed line. So now I'm going to use that same test point, because 0, 0 is not on the line. So when I put 0, 0 in for x, I put 0 in for y. Just like always, you'll always end up with 0 on the left is less than -4. Now 0 is not less than -4. 0 is to the right of -4 in the number line. So that is also false. So I would not shade in. I don't want to shade in the side for this. That would cover up 0, 0. So we shade on this side of the red line. So we want to shade it. So our final solution is going to be the region that is covered in both red and purple. So that would be this region right there. So anything in that sliver, that would continue to flow down, but anything in that area would be a solution to both inequalities. All right, let's look at one more together. This one has a system of 4 inequalities. So let's do the same thing. I kind of like that, waiting to, using a test point after each inequality as opposed to waiting to the end. So you might find that a little bit easier as well. So let's look at this one. So the first one, if I did this one in red, we'll have an x-intercept of 6. So put a point where x is 6. Find the y-intercept. I'm going to divide both sides by 3. So when I do that, I get a y-intercept of 2. Look to see what kind of line we use. It's going to be a solid line. Okay. Now we're going to see what side we shade on. So I'm going to test 0, 0. Do my test up here. So if you always use 0, 0, because you can use 0, 0 as long as it's not on the line. If 0, 0 is on the line, just use a different point and you test it the same way. But in this case, if you ever use 0, 0, the left side will just all be 0. So we get the statement 0 is greater than or equal to 6. That is false. So I don't want to shade on the side of the line that 0 is on. That test point was on. We don't want to shade the side of the line where the test point is on because the test point proved false. All right, so now let's do the other one. So we'll do in blue. The x-intercept is at 2. Find the y-intercept. Cover up the x. Now this time we have negative y in 2, so I would divide both sides by a negative, which would result in a -2 for our y-intercept. And there is no line underneath here, so we connect these with a dashed line. So always look to see what to connect these with. So now we're going to use the test point. We can use 0, 0 again because the coordinate 0, 0 is not on the line that we just graphed. If I do that, I get the statement 0 is less than 2. That's true. 0 is less than 2, so I'm going to shade on the side of the line that has our test point. So that would be on this side of the line. All right, so right now my feasible region is at that area that we have the blue and the red lines, but we still have these other 2 inequalities. Okay, let's talk about this one here. So x is greater than or equal to 0. If I had the equation x equals 0, that's a horizontal line. I'm sorry, I was thinking y equals 0. If we have x is greater than or equal to 0, that would be a vertical line going through where x is 0. And y is less than 4. That would be a horizontal line, and we would use a solid line, by the way, for that. And as far as what side of the line we would shade on, we're starting to get a lot of shading here, so I'm not going to shade on this side, but we would end up shading on the right side of the line. And so on the right side of the line, it would be greater than 0. So think about the x-axis. To the right of 0 is positive. It's bigger than 0 to the right of 0. And so this one, y is less than 4. We would have a horizontal line where y is 4. If it's a horizontal line where y is 4, we would shade below that line because it's less than 4. Less than means below. So the area that, so think about this. So we have this horizontal line and the vertical line. So the area that's below the horizontal dashed line that's to the right of the vertical line that all four graphs have in common would be this one here. So those get a little bit trickier. Sometimes I'll give you a hint. It's a little bit easier if you first start. I didn't want to do it for these two, but sometimes it's easier if you first start with these two kind of unique ones, because what that's going to do is that's going to tell you what area we're going to be focusing on. So if I had just started with those, let me just erase some things here. I would have been able to start saying, okay, my feasible region is going to be in that area here somewhere, and then we could narrow it down to figure out that it would be just inside of that section. All right, I know that's a lot, but I want you to try this next one on your own. Do as much of it as you can, and if you can't do the graphing or the shading part, don't do the shading part, but I want to see how much of that you can do on your own. So pause the video and hit play when you're ready to check your answer. All right, let's see how you did here. So what I was talking about in that previous example, I'm going to do that on this one. So we have x is greater than or equal to 0. So x is greater than or equal to 0, that's going to be a vertical line going through where x is 0, and it's greater than 0. So I'm going to do this just to help me that we're going to tell me that we're going to be focusing on the right side of that graph. Y is greater than or equal to 0. That's going to be a horizontal line going through where y is 0. And we're going to be shading everything above that line where y would be positive, where y would be greater than 0. So right now, if I just did that, my feasible region would be quadrant 1. Okay? That's not going to be the case. We have these other two lines. So now let's graph the other two lines. Do this one in red. So my x-intercept, if I cover up the y, my x-intercept, -2 divided by 2 would be -1. So my x-intercept's at -1. Find the y-intercept to cover up the x, and then I have just the statement y is -2, so we'd have a y-intercept of -2. So I would connect those with a solid line. So now let's use a test point of 0, 0. When I use 0, 0, we would get the statement 0 is bigger than or equal to -2. That is true. So then looking at my line that we just drew, here's 0, 0. Yes, it's on the green lines, but that's okay. It's not on the red line. So we would shade to the right side of this line. Now, I really don't care about everything, so that just tells me that, yes, right now, my feasible region is still that yellow region. Okay, so now let's do the next one. So the next one, we would have an x-intercept of 2. If we cover up the y, we would get an x-intercept of 2. And a y-intercept, if I cover up the x, we get a y-intercept of 1. And then these we would connect with a dash line. That's really all I would need, because now if you look at what we just did, we just cut that yellow region in just a small little sliver, and then there's a bigger section. So my feasible region is either going to be in that little triangle or in the bigger region. So to figure that out, let's use our test point 0, 0 again. I would get the statement 0 is greater than 2. That is false. 0 is not bigger than 2. So we don't want to shade in the side that has the test point. So I'd shade on this side of the line, which if you notice means that the one area that would work for all four equations would be this area here. So I could keep shading. I'm not gonna. I'll stop there. So that would be my feasible region. So everything in that point, anything in that area would work and make a true statement in all four inequalities. All right, so I know that was a lot to take in there. Hopefully, you at least understand how to solve or graph basic linear inequalities where we just have two. That's the most important part. So go ahead and work on your assignment now.